Hi, this is Leetcode question. Apply operations to make all array elements equal to 0. This is the last question of week 11 test number 353. Now, to solve this question, what we will try to do is try to make all the elements equal to 0 starting from the first index. So starting from I equal 0, we need to make this element equal to 0, but remember the window or the subarray size should be of length k. So we need to make this 0, and this will affect 3 elements. So here we will subtract 2 minus 2 is 0. Then we need to solve for I equal 1. Now for I equal 1, we need to make this 2 equal to 0, but we already have 2 subtracted from the previous element, so 2 minus 2 also 0. So no need to do anything here. We need to solve for I equal 2. To make 3 equal 0, we have already 2 subtracted, and we need one more, which is 3 minus 2, 1. So here we have 3 minus these 2 equal 0. And remember this one, because we just subtracted 1, this will affect 3 elements. So here 1, 1. Then we move to solve for I equal 3. Here we have 1, and we need to subtract 1. So we have 1 from the previous element, so no need to do anything, because 1 minus 1 is 0. And for I equal 4, we will not do anything other than checking if, because the window here go over above the array limit, so all what we need to do is to check if 1 and the summation here is equal. So here we have 1 and 1, and this is equal, so 1 minus 1 is 0. 0, we don't have anything here, so it's 0, and at the end we return true. Let's take another example, 1 3 1 1, where the answer is false. 1 3 1 1 and k equal 2. So we start from this index, and this is the length of the window. We need to make this equal to 0, so we subtract 1. Then to solve for this one, we need to make it 0, but we have 1 from the previous window. So to make this 0, we subtract 2, which is 3 minus 1, and subtract 2. Now we need to make this 0, but 2 is greater than 1, so it's impossible to make this equal to 0, and in this case we return false, while in this case we return true. Now we need an efficient way to store these values, and to do that, let's say I want to solve for a specific index I equal 3, because I know the length of the window is 3, so I need information about what was the added or the subtracted value at this index, so that I know what to do with this current index. I need the value subtracted at this index, and I need the total sum or subtract sum at this index, so that I decide what value to subtract from this. Let's see how this works. So subsum, subtracted sum so far equal the first element 2, and we have vector or subtracted represent the value of the subtracted value at each index. So the first index it's 2. Now let's try to solve for I equal 1 here. We check if the window I minus k, I equal 1, 1 minus 3 is minus 2. Is it greater than 0? No. So no need to subtract anything here from the subtracted sum. Then we check if the subtracted sum here 2, because we subtracted 2 here and it will affect this value also. Is 2 greater than 2? No. That means we need to subtract from this value the difference between 2 and the subtract sum, and in this case it's 0. So we subtracted 0 from this index, and the subtracted sum so far is 2 plus 0, which is again 2. Then we need to solve for I equal 2. Now again we check if this element previous to the window is greater than or equal 0, and the answer is no. Then we need to check if the subtracted sum so far is greater than 3. Answer is no. And what we need to make this 0 is 3 minus 2 equal 1. So we already subtracted 2, and if we subtract 1 here, we will make this equal to 0. So we push 1 to subtract it, and so far we subtracted 3, which is 1 plus this 2. Then we go and fix for I equal 3. Now this is the size of window, and these are the elements that affect this index, and so we need to subtract the value that we used in this index to update our sliding window. What was the value subtracted at this index? It was 2. So here we remove this from subtracted sum because this is no longer affect this index. So we have 3 here minus the value at I minus k is 2. I is 3. 3 minus 3 is 0. The value at 0 is 2. 3 minus 2 equal 1. And so we update this value to 1. And this means the subtracted sum from these elements up to this index is 1. Now we need to check if 1 is greater than 1. Answer is no. So what we need to do is to make this 0. 1 minus 1 is 0. So we only need to subtract 0 to make this equal to 0. And 0 plus 1 is 1 again. Then we need to fix for I equal 4, but notice here the window from 3, because we want to make this equal to 0, from index 3 it reached the end. Now if we want to fix for this, the window will go outside, so we stop at I equal 3 and we start another loop. In this loop we need only to check if the sum total sum so far is equal to these elements. So here we have 1, and the subtracted sum is 1. Now this one is affected by these elements 3. So what was the value that subtracted from at index 1? It's 0. So 1 minus 0 is 1. Now we check if this one equal to 1. It's true. Then go and fix for this element, and for this element we have this window. These are the elements affected by this index. What was the value subtracted at this index? It's 1. That means from the total sum or sum we need to subtract 1. 1 minus 1 equals 0. Now is 0 equal 0? Yes, that's it. We are done. In this case we return true.